Hi guys, day 2 of unit 1. So we're talking about function notation and also the intercepts of a function. Right? So top part of this is just a little reminder that, x is the input, y becomes the output, and y and f of x are synonymous with one another, right? So when it says recall, function rules come up in 3 forms. So equations, graphs, tables, don't worry about where it says the warm-up part of it. We are going to jump right on in to the notes here with a little example and using the fact that we have a table going on here. So when it says boiling water at 212 degrees, 212 degrees Fahrenheit is left of the room. That's 65 degrees Fahrenheit. Ooh, kind of similar to the room I'm in right now. And begins to cool. Our heat wasn't working earlier. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours H. Right? So if it helps, you can always say, it's normally, f is a function of x or y is a function of x. So the number of hours H, that is like our x value, right? And then our temperature T, that's like our y value. So sometimes it helps to kind of see it there. So when it says evaluate T of 2 and T of 6, they're simply just saying what y values, or in this case, T values, match with each of these. So go over to 2. So T of 2 equals 104, and then T of 6 equals 68. And so now what the heck does that mean? Well, that means at 2 hours in, the temperature of the water is 104 degrees. And then after 6 hours, the temperature is 68 degrees. For what value of H is T of H equal to 76? So just look along here. There we go. And then you're working backwards there. So T of 4 equals 76. So at 4 hours would be our answer there. And then between what 2 consecutive hours will T of H equal 100? So T of H equaling 100, just take a look back in the table. So let me slide back a little bit. So we can see where it's 104, we see where it's 85. So in between here, somewhere in between those 2 time marks is when it's actually going to hit 100. And consecutive hours just means in a row. So between hours 2 and 3, right, is when it hits 100 degrees, somewhere in that range. That's it for that first example. Go ahead and flip it right on over to the next page. I'm going to slide my paper back here. All right, this time we're using a graph to be able to interpret. So we did one with the chart. Now we're looking at a graph one. So it says the function y equals f of x is defined by the graph shown. So this is the function f of x. They're not giving us an equation, just giving us a graph. Answer the questions based on that. All right, so the first one, it says evaluate f of -1, f of 1, f of 5. Remember that this means it's just a point. So if I say, what is f of -1? That's like me saying, all right, go to x equals -1. Tell me what the corresponding y value is. So on your graph, note here's your x-axis, y-axis. If I go to -1, there's the point right there. So the y value is simply 0. Right? Because that's the point -1, 0. So just keep that in mind. So then f of 1, go over to 1 on the x-axis, and then go up until it hits. That would be the point 1, 2, 3, 4. Okay, and then f of 5, go over to 5. So 1, 2, 3, 4, 5, and then you're going to go down 1, 2, 3, 4. So that's going to be -4. Right, so those are all obtained by just looking at the coordinate points on the graph. This is the point 1, 4. That's the point 5, -4. Right? So when it says evaluate f of 0, so first of all, f of 0. So go up 1, 2, 3, and there it is. So f of 0 equals 3. When it says what special feature on the graph does f of 0 always correspond to? Right? Well, special feature just means like what nice name, do we have for that? So when x is equal to 0, we have the point like this, x, and then y. That is referred to as your y-intercept. Which really just means where it crosses the y-axis. When we hit the next one, what value of x, or what value, of x solve the equation f of x equals 0. All right, so last time, f of 0, that was when x was 0. Now we're saying what values of x will make the graph equal to 0. So in that case, we're looking at the point as being something, comma, 0, all right? Which when I think of it that way, that means whenever y is equal to 0, that's the same as saying it's on the x-axis or their x-intercepts, right? So if you look at this particular graph, I'm going to slide back here, there's 1, 2, 3 of those. So that's happening at -1, 1, 2, over at 3, and 4, 5, 6, 7, over here at 7. So what values? That would be at x equals -1, 3, and 7. If you like those curly brackets, there's your time to shine. Otherwise, just write them, box them in, call it a day. All right. So when they're on the x-axis, those are your x-intercepts. The other name, let me just double check that you guys can see everything okay. Good, that you can. The other name for x-intercepts would be roots, sometimes called the zeros as well. Right? So, or sometimes we'll abbreviate to x-ints. We just mean intercepts. All right, so all of those can be used as the same thing interchangeably. All right, the last part of this one, between what two consecutive integers, so in a row, does the largest solution to f of x equals 3 lie? All right, so let's think about a couple things here. So if f of x equals 3, that's the y value. So I want something, comma, 3 here. So I can go and actually draw the line y equals 3 onto the graph. So I'm going to slide this back down. If I do that, so I've got 1, 2, 3, drawing it in red so that hopefully you can see it a little bit better. All right. When it says which one is the largest solution, well, the x values get bigger as we head further to the right. So if there's 1, 2, 3 solutions, this one would be the largest because it's furthest to the right. So you can tell it's not crossing in an exact integer value, but it should be between 7 and 8 that solution lies. One second here. There we go. All right. So I would say between, ooh, I'm still in red, x equals 7 and x equals 8 is the largest solution. All right. And literally, because it's furthest to the right. All right. The next little example, not related to that graph. This one's a little bit different. It's saying for a function, we have y equals g of x. It's known that g of -2 equals 7. What coordinate point do you know is on the graph? Don't overthink it. This is going to be your post-video question. So what coordinate point should be on the graph based on that right there? All right. All right, let's keep on moving. So the next thing, sorry if my arm's in the way. I'm just not left-handed and not coordinated with that. The next thing we're going to look at is talking about the intercepts of the graph. So when we have x-intercepts, y-intercepts, we kind of mentioned them above, but a couple things. Simply means it's where it's crossing that particular axis. So the x-intercepts are where the graph crosses the x-axis or the horizontal axis. Sometimes that's good to know. Mm-hmm. There definitely can be more than one x-intercept. On the same graph. Mm-hmm. And then how we solve for it is you would set y equal to 0 and solve for x. If we were to do it algebraically, because the ones we did above, we just looked at the graph and figured it out from there. Mm-hmm. Whereas if we're talking y-intercepts, kind of a similar scenario, but this is where the graph crosses the y-axis or the vertical C-A-L. Super misspelled, just saying. So it crosses the y-axis. For when it's a function, it can only have one y-intercept. All right, if it's not a function, then yeah, it can have lots of them. But if it's going to be a function, it can only have one. Otherwise, it would fail the vertical line test. And then algebraically, you're going to do the reverse. So for a y-intercept, set x equal to 0, and then you're going to solve for y. Right. If need be, you can always pause the video and make sure to get all that down. Let me double check that you can fully see everything that I'm writing. So let me quick switch my screen there for a second. Whoops, I'm a little crooked. All right. So if you need to, pause it, and then you can resume when you're ready. All right. We have one last page with some examples to look at. So on the last page here, let me drop on down. It says determine graphically the x and y-intercepts of the following functions. Write your answers as coordinate points. All right. If necessary, approximate the value to the nearest tenth. Excuse me. All right. So x-intercept of this first one. Count carefully. If here's 0, we're backing up 1, 2, 3, 4. And then here we're at 2. So for the x-intercept, don't just write -4. It would be -4, 0. For your y-intercept, same thing. Don't just write 2. You would write 0, 2. So think, if you need to, x, y, x, y. Pay attention to that. All right? For this next one, the x-intercepts, we should have 2 of them here. So one at 0, 1, 2, 3, 4. The other one at 4. So 0, 0, and 4, 0. For the y-intercept, that one is also 0, 0. So if the x-intercept 0, 0 and it's a function, the y-intercept has to be that 0, 0 as well. All right, the last one, we're going to approximate. So using our best ability to kind of guesstimate, we've got an x-intercept here and an x-intercept here. So maybe somewhere between 0 and 0.5, maybe we'll go 0.3, 0. And then let's see, maybe 1, 2, 3.7-ish. Right. So hence the approximation. And then the last part, the y-intercept, I would say you're looking at 0, 1. That looks exact, that it's right on that point there. Right. For the next ones, do a little algebraic practice now. It's saying determine the x and y intercepts of the linear functions. So this is where you're going to use that rule that to find the x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0. So it's always the opposite variable that you set equal to 0. All right, we'll try to keep this organized. So for x-intercept, let's set y equal to 0. So plus 0, which just means you're going to get 2x equals 10. Divide by 2, we'd get x equals 5. So that would be the point 5, 0. For the y-intercept, go the other way around. 2 times 0 plus y equals 10. And right there, bam, there it is. So 0, 10. Now, because it's linear, could you get it into y equals mx plus b form and get that b value all by itself to get the y-intercept? Yes, you can. All right, so I'm not trying to undo anything you knew from before. It's just you don't have to have it in that form and you can still answer it. So let's do one more here. So same thing, x-intercept, plug in y equals 0. So 3 times 0 minus 2x equals 6. So we get negative 2x equals 6. Divide that negative 2 on out, and you're going to get x equals negative 3. So negative 3, 0. And then for the y-intercept, flip-flop it. All right, so 3 times y. So basically when I plug this in, it just wipes that term right on out. I'm going to try to squeeze this in here so I get y equals 2. And so I should have the point 0, 2. And then if you were to plot those points and connect the dots, the line that results should be the line that you would get if you rearrange it into mx plus b. Maybe we'll save this guy over here for a little recap the next day in class. Last one. I love this question. All right. Saying physics students, whoops, went a little too tall there. Physics students drop a ball from the top of a 50-foot high building and model its height as a function of time given by this. So use your calculator to determine when, to the nearest tenth of a second, the ball hits the ground. All right. It doesn't have to be gorgeous, but maybe a little diagram. So over here, there's my building, and I'm saying it's 50 feet high. All right. So there's 50. Because my building is going to be part of my y-axis, essentially. All right, and then I've got my little x-axis here. Oops, or I should say t, and then h of t. So here's my height. T is given by time in terms of seconds. All right, so it's a good idea to try to label things, appropriately so it matches the context of the question. So you've got height on the left, time on the right here, or I should say the vertical and the horizontal. All right, so grab your calculator. And now into the calculator, of course, we're going to type it in as y equals 50 minus 16x squared, but it's still going to be the same thing. So let's get that 50 minus 16x squared. I'm just going to zoom 6 just to reset because I don't remember where my screen was last. Okay, now a couple things. It's saying it's starting at the top of a 50-foot tall building. So my window, I'm going to have to at least take that y max up to 50 plus. So what I mean by that, if I go to my window, maybe I'll make my y max like 60 just to give myself the space. Right. And now you can see that upside down parabola. I don't really need to see anything to the left because we don't care about negative time. So you can leave it like that, or you could choose to change your window so that the y minimum is, 0. And then you would only see that portion of it. But that's up to you. Use your discretion there. All right. So kind of just sketch what's going on. Starts here, comes on down like this. All right. So it says use your calculator to determine to the nearest tenth of a second when the ball hits the ground. So if this is the path of the ball, then where it hits the ground would be right here because your height should be 0. All right. And they're asking you to find the time. So you want to solve for t, or if it makes you feel better, you can think of that as x, all right? So right here, we'll talk about algebraically how to do it, but this one's saying use our calculator. So on the first unit that we had, unit 0, you guys had a calculator reference sheet, and I believe this process was on there. So to solve for an intercept, you can do second, and then trace. So let me get my calculator up here so you can see it. So if I go to second and then trace, what you're going to see here, you have value, 0, minimum, maximum, intersect. We want to calculate when it hits 0, right? That's another name for that x-intercept. So second trace 0, which is that choice 2 there. And then it's going to ask you for a left bound, a right bound, and to take a guess. All right. So in this case, I'm going to arrow over so I can see it. Oops, maybe I went a little too far. Let me backtrack here. Where are you? X equals, my numbers are getting more and more negative. Hold on. I'll get back into the realm. All right. So if you can't find your cursor, let me try that one more time. Second trace 0. I think I must have hit something. Negative. There we go. Holy moly. All right. So left bound. So on my graph to the left side, here to the right side is here. So there's my left bound. There's my right bound. All right. Oops, that got a little squishy there. All right. So second trace 0. I'd hit something. So that's why I redid that. All right. Left bound. Hit enter. Slide over to a right bound. You should have those 2 arrows now pointing at each other. Those guys right there. Let me zoom in a little bit. Right. And then when it says take a guess, get as close as you can to it and hit enter. So I have 1.7677 and it keeps on going. So my x, or really my t value here, comes out as that. So to the nearest tenth, we would say that t is equal to 1.8. And then remember the context, seconds, until it hits the ground. So that ball is launched off the top of the building. And not quite 2 seconds later, it ends up hitting the ground. There you go. All right. As always, remember to answer the question once you exit out of here. Thanks, guys. Have a good one.